Good morning and welcome to YouTube channel of Lucky Institute of Professional Studies. Today we are going to discuss about process management in operating system. Now whenever we talk about computer system, there are three basic functions will happen always. First, we'll be giving some input to the system. That input will get processed by the CPU and after that we'll be getting the output. Today, for explaining all the process states which are happening in the operating system, I want to give an analogy of a bakery system. How program, process, what are process, how they works. Now, with this analogy, let's see. We have customers, we have bakers and baker, and then the baker will be doing the process, and after that we'll be getting the output. So the input is our customers, and then CPU is our baker. Finally, we'll get the output which we'll be delivering to the customers. Here, orders will be placed by the customers. Those orders will further be transferred to the CPU, that is baker, and this process, what will baker do? Baker will process the request which has been given by the customers. Then this process will also be having few other customers who are waiting. So where they are going to wait? They are going to wait, or their orders will be kept in the ready queue. Why? Because these orders are waiting for the baker to get their chance to be executed. Then who will give the chance that next which order should be placed? For managing that, we'll be having manager, and in technical terms we'll call it as CPU scheduler. Then lastly, there will be few people who will be waiting for their orders to be processed. So what they should do? They'll be kept in the waiting queue because they are waiting for the services. Those services will be given by the CPU. Right? So here, when we say then program, that is a recipe, and the execution, which is the baking part, these both together makes a process. So process is what? Process is here, that is CPU or baker will be doing the work which has been placed, or will be ordering, will be processing the order which has been placed by the customers. So now let us understand by a simple technical example before I go to the process states. Now what will happen here? Here, whenever we give any task to the computer, then the task has been created. So that state will be called as new state. It's not necessary that at the same time, at a single time, we are giving single task to the computer. There can be multiple programs which are running on the computer. For example, we are opening Chrome also, we are listening to the music also. So all these processes will be in the new state. Now, among them, if we talk about now uniprocessor system, let's talk only about uniprocessor system, that we are having one CPU. So one CPU will execute one process at a time. Now I have multiple number of processes here, out of which Procy is getting a chance to go to execute. Now it will be in the ready queue and Procy will be starting its execution. Once it starts its execution, while it's in the running state by the CPU. CPU is doing the task which Procy has requested for. Once it's done its task, what will happen? It will, if it requires any input output device, then it will be sent to the waiting queue. There it will wait. Once its task is, or its input output devices are given to it and it executes, it does its work. After doing that, if all this work is completed properly, then what will happen? Proceeds, complete work is done and it will terminate. This is the simplest states in which the process executes. Now, what is this suspended ready and suspended block? This I am going to explain with the process state diagram. Basic process state diagram is new, ready, running, wait or block, and terminated. Let's start with new. Now, what is happening here? For example, whenever we are starting our laptop or we are starting our computer, the first thing what happens is OS is mounted, right? So where this work is happening? This work is happening in secondary memory. Now, there will be size of secondary memory also and RAM also. So whenever the OS has been mounted, that means the process has been created and its state is new. As soon as we load this, all the programs, there will be multiple processes which are here in the new state, but because we have secondary memory size bigger than that of RAM size is limited. Secondary memory now we get, for example, 1 TB also. But what happens to RAM? For example, it is 4 GB, 8 GB, or 16 GB. So we cannot get all the processes which wants to execute in the ready queue at the same time. We can get only limited amount of processes here. So what we'll do is, we will get the processes from secondary memory to RAM. Like, so who will do this task? This task will be done by long-term scheduler. Long-term scheduler is responsible for getting the processes from secondary memory to RAM. After this, all the processes which are ready, they are ready and they are waiting that somebody will take, that is where they will go. They will go to CPU. CPU is responsible for executing the processes. So what will happen? They will be sent to the CPU. In this, running state means they have started their execution. They have already started their execution here. Fine. Now, in their running state, once they complete their execution, next what will happen? Once they have finished, they will go to terminate state. This is case 1. When simple, the process has come to the ready state. Now, when we are talking that the memory is limited here, then how the processes, for example, I have 5 processes which have been sent in the ready queue. Then here, we'll maintaining the queue which will be known as ready queue. In this, all the processes which has been sent will be waiting to go to running state. For example, P1 got the chance, it did its execution, and finally the state will be terminated. This is the simplest case when the process is not waiting or it has not been interrupted by any other process, nothing has happened and it is executed properly and it got terminated. This is the case 1. Now, talking about case 2, what will happen? For example, there is any process which came and it said that I am of highest priority. I have a tag of VIP or VVIP. So what should I do? I have process P1 which is executing and process P2 comes with a tag of VVIP. What should I do here? This running process P1 will be sent to or dispatched. It is interrupted and it will be dispatched to ready state again. Why will it be dispatched? Because there is a process P2 who has got a tag of VVIP and it has to execute first. So what will happen? It will go back to this. Now there are 2 things here. The process is of high priority. That is why this has been done. Or second thing can be the time quantum has expired. Now what is time quantum? In time quantum, what we give for every processes, we fix the amount of time. For example, 5 milliseconds I have fixed. Process P1 will get 5 milliseconds, P2 will get 5 seconds. Automatically, after that, the process will come from running state to ready state. So these are the 2 cases in which we'll shift the process from running state to ready state. Now, there we can talk here about 2 things, that is non-preemptive and preemptive. What do we mean by non-preemptive? For example, when a process is in running state and another process comes of higher priority, the process which is in running state will not give its CPU to any other process before finishing its execution. So it will complete, it will get terminated, and then only it will give CPU to any of the process, whether it's of high priority or not. So in this case, we call it as non-preemptive because it is not giving its CPU before completing its task. Second, when we talk about preemptive, in preemptive, what happens is we have a process and higher priority process comes here. So that time what it will do, then and there it will pause and it will come to the ready state. So it has completed few tasks. This here I'm also telling the concept of multitasking. What will happen in a process? There will be number of tasks. It has finished few tasks, and because of high priority process which has come in, it's going to ready state. So here it has completed few tasks, but few others are remaining. So this concept is preemptive also, and it is also using multitasking, right? Then now we have the next case in which what will happen. Now the process which is in running state is asking for some IO device. For example, it want to, before finishing, it want to read any file, or it is asking, it needs printer or scanner or any IO device. So what will happen? The CPU will tell, okay, go in the waiting state so that my time is not idle and I can start executing some other process. So what will CPU say? Here who is sending? Here process was going by itself. Here CPU is putting it into waiting state, and as soon as this work is done, this is input output, it's got, this process has got what it required, that is it's already read its file, or it has got its printer, scanner, whatever required. What will happen? The input output request completed and it will go back to ready state. This was next case. Here what will happen? Here also our process is in RAM. Here it was in secondary memory. Here it is in RAM. Here also we are using RAM only, right? Only the address will change, that it is shifting from one place to another. Again here our process is in RAM. Again it will go to ready queue. The process will go in running state. Then for example, with this, it will start ready state, running state. If it is done with its blocking, all the things are done, it will terminate. This was the case 2. Next, let's talk about case 3. In case 3, what will happen? Let's take an example that I have 5 processes. It comes in the ready state, it goes in running state, and it says that okay, fine, now I want input device. Second process comes and does the same, that it goes in the waiting or blocking state. Same things happen in the third state. What a third process also says, that I want to wait, I am getting blocked, so I want to wait and I have to take the input device. Same happens with fourth and fifth. Now what to do? All these are asking for wait and block, but I have a limited size. Here I have waiting queue, which has been filled. Now next process comes, that is sixth process. What to do? I don't have space here. What will I do here now? So what I will do, I will introduce a next state. What is that next state? That is suspended wait. I will say that process go to suspended wait and wait there, sit there. Where is this? Now it's not in RAM, it's in secondary memory. Why we are doing this? We are doing this because now the queue is full. I don't have space in RAM. Here previously only I said that RAM is limited. Secondary memory we can have size more, but RAM is limited. So I have to shift this in suspended wait. Who is doing that? Here we'll be using medium term scheduler. Same as we use long term scheduler here when we are shifting the processes from ready to running state, we are using short term scheduler. And here when we are shifting from waiting state to suspended wait, this task is being done by medium term scheduler, and this is happening in secondary storage. Now as soon as here we get space, any of the process is done and we get next space which is empty, what will happen? This will again come to waiting or block state, and now When this work again it's done, it will go to ready, running, and this way all the processes will be done, right? Now when we talk about these 5 processes, all these 5 processes are next state. Our next state is suspended ready. Why do we need this state? As I told, secondary memory is larger, RAM is limited. So at a time I can put only 5 processes here. Now the 6th process comes to this state. What should I do? I will have to put it in suspended ready. Again, this task is being done by medium term scheduler. And as soon as this happens, that ready queue is empty, the process which is waiting in suspended ready will come to here and start executing again. Now what happens if we have, what we have to do is suspended wait. For suspended wait, what we have to get it into first this state, then we have to get it in ready queue. Now what happens if it is waiting in secondary memory for large amount of time? We can do one more thing, that we have to get this in ready state. Either we can get it this way, this channel, or we have one more thing. What we can do is we can shift it here from this to this place. This is known as backing storage. That don't wait here. You can also go there in suspended ready queue, and as soon as this will get empty, you can enter here and you can proceed further, right? So in this, we have completed the concept of long-term scheduler, medium-term scheduler, short-term scheduler, preemptive, and also non-preemptive. Plus, we have also learned what is multitasking. One more thing with multitasking I can add, that is multi-programming. What happens here is, yeah, when we are putting our processes from secondary memory to RAM, n number of processes are coming here. That is known as multi-programming, because we don't have a single process. We have n number of processes which are entering in the ready state. So this is known as multi-programming. So here, these are the process states which can help you in your examination, because previous was the analogy with diagrammatic representation. So to remember this, to learn this, I have put a tagline: new, ready, run, wait, and suspend, resume, and terminate. This can be a punchline which you can learn to put it down in your examination. Thank you.